Welcome to Algebra Quiz 6. This problem was posted on the 24th of October in my blog vijayrahavendran.wordpress.com. It's taken quite a while to provide the solution for this quiz as I was very busy with my work as well as teaching at Brockett Park. This problem was taken from Pure Mathematics for Advanced Level by Bunday and Mulholland from 1973. So let's tackle this problem. Okay, so I open Outrage, and there are several different ways of doing this problem. When I posted this problem 3 years ago on the notice board in the school, one student gave the answer as u is equal to 6 and v is equal to 6. He merely guessed it and he got the right answer. However, on closer inspection, when we rearrange these equations, it's a simultaneous equation in higher order, we should get 3 solutions. So let's see how we're going to get all 3 of them in a systematic way. Okay, so I'm going to erase this one and start off with the simplifications. So the first step is the equation 1, which says is u square by v plus v square by u is equal to 12. So what I did was taking the common denominator and adding the numerator. Okay, so when I do that, I get u cubed plus v cubed divided by uv is equal to 12. So that's from the first equation. Okay, and then from the second equation, doing the same process, what I get is u plus v is equal to 1 over 3. So now I get a nice equation where there is a u plus v and a cube of those terms and the uv. So there is some similarity between these 2 equations. So I'm going to go about and simplifying it further. So the first thing I do was, so I take this one here, so I do u cubed plus v cubed is equal to 12uv, and I expand this one as a cubed plus b cubed is equal to a plus b times a square minus ab plus b square. So I write u square minus uv plus v square is equal to 12uv. And then I'm going to substitute for this u plus v from this equation. So the u plus v is going to be uv divided by 3. So it's going to be uv divided by 3 u square minus uv plus v square is equal to 12uv. So what I get is u square minus uv plus v square is equal to 36. So in this problem, what they're asking us, these 2 represent a curve. Where do these curves intersect? That's what actually we're trying to do. So we have tackled this by substituting the relationship between u and v from one into another. And we have gotten so far. We can't use quadratic formula for this because we've got 2 variables, u and v. Quadratic formula can be used if it was only 1 variable. So we need to do further simplification. Okay, how about if I do squaring, completing the squares? So if I do that, so I can do u plus v whole square. Sorry, there's a bit of a mistake here. So I'll do u plus v whole square, which will pull the u square term and the v square term, and then I get a 2uv there. So I need to take 2uv away from this one to get back to that one. So I get minus 2uv, and then I've got a uv already, so it's going to be 36. So what I now get is u plus v whole square minus 3uv is equal to 36. So going to start off here. So uv and u plus v are related by that equation there. So I can write uv as 3 times u plus v. So I get, on further simplification, u plus v whole square minus 3 times u plus v should be equal to 36. So I get an equation in terms of u plus v as a variable. So I get this one, minus 9u plus v minus 36 is equal to 0. So now I can substitute for u plus v as a new variable called x, and then I get x squared minus 9x minus 36 should be equal to 0. So from which I can solve for x as x is equal to 12 or minus 3, which means that u plus v must be equal to 12 or minus 3. Okay, so I've gotten so far converted the square term to a linear term. So I've got yet another relationship between u plus v, u and v I mean. Okay, so I'm going to use the first one here, u plus v is equal to 12, and I'm going to take this one here, uv is equal to 36. So uv from this relationship is going to be 3 times u plus v. So that becomes u plus v is equal to 12, so that becomes 36. So I've got u plus v is equal to 12, uv is equal to 36. So I've got two equations with two unknowns that we know how to solve this using quadratic formula by substitution. So I can substitute for v or u from this relationship here. So when I do that, so let's say u times 12 minus v, or u, I mean 12 minus u should be equal to 36. So this, when expansion, it will give me a quadratic equation which will give me in the end u is equal to 6 or v is equal to 6. Okay, so I get one equation, a solution to this intersection, 6 and 6 as one of the solution which I mentioned right at the beginning. I've used only u plus v is equal to 12. I need to use now u plus v is equal to minus 3 and go about doing the same thing now to find out the two other solutions. So when I do that, I'm going to use a different color for that. So I've got u plus v is equal to minus 3, and so uv should be equal to 3 times u plus v, which should be equal to 3 times minus 3 should be equal to minus 9. So now I've got a relation which is u plus v is equal to minus 3 and uv is equal to minus 9. So I can go about solving this equation just as the way I did earlier for these two sets. So when I do that, what I would get is I would get u is equal to minus 3 over 2 times 1, sorry, it'll be plus 3 over 2 minus plus minus square root of 5. So I get that as u. And then when I substitute for u in this equation and solve it again, I would get v as minus 6 divided by minus 1 plus minus square root of 5, which on further rationalization of the denominator I can which is same as minus 6 divided by minus 1 plus minus square root of 5 minus 1 minus plus square root of 5 minus 1 minus plus square root of 5. So to rationalize this denominator, so what I get is minus 6 divided by, this would be like a plus b times a minus b. So it's going to be minus 1 square minus square root of 5 square and minus 1 minus plus square root of 5. So it's going to be minus 6 divided by minus 1 square is plus 1 minus square root of 5 square is 4 minus 4 here, and then minus 1 minus plus square root of 5, from which I get 3 over 2 minus 1 as the solution for v. So now we've got 3 different solutions. U is equal to 6 or v is equal to 6. You've got u is equal to 3 over 2 times minus 1 plus minus square root of 5, and v is equal to 3 over 2 times minus 1 minus plus square root of 5. So as expected, it's this problem, the intersection of the curves has got 3 points. On further inspection, okay, before going into that, I plot the values of this problem onto Wolfram to see what Wolfram gives. So wolframalpha.com, that's a fantastic website for all kinds of database queries or mathematical, you name it. So I gave the problem to Wolfram. So Wolfram, they plotted it, and that curve there, it's got a famous name. It's called folium of Descartes. So I'll come more about it in a minute. So that's the folium, and then this one here, that's the 1 by u plus 1 by v. So the intersection of that, that's these 2 points that we are looking at, and then there's one here as well. Okay, Wolfram solves it and he provides the answers here. 2 years ago, we could get the entire solution to the problem from Wolfram, but now they made it as a pay per basis. Okay, so to go more into the folium of Descartes, I was saying, okay, how can I plot that curve? So I went into Excel, and then we see that you can't separate this equation, no matter how hard you separate the variables. So I'll have to explain it, what it means. So this is what I'm trying to plot. U cubed plus v cubed is equal to 12uv. To plot this, I need to get u in terms of v or v in terms of u, and I can no way get that because I just can't do it, because they are called implicit functions, because it cannot express one in terms of the other. However, the fact that we can draw curves for this means that we have to go about doing this in a circuitous way by using what is known as parametric forms. And then searching on the web, I found this a PDF, which I'll be posting it on the blog as well, a link to the PDF. And they say how we can do parametric curves for functions, implicit functions. So let's see how. Okay, here we go. Folium of Descartes. So what they did was, they say here, because of the x cubed and the y cubed terms, the equation of the folium is not easy to solve for either x or y, but there is a useful set of parametric equations for this curve, and to find this, we choose a geometrically meaningful parameter. In this case, for each point x, y in the curve, we will let t be the slope of the line through the origin to the point x, y. So they define t is equal to y over x as a new variable, and they solve for x in terms of t, y in terms of t. So now we get x and y points, and this we can plot it. And this is what I did on Excel. So I got this. X is equal to 380 divided by 1 plus t cubed, y is equal to 380 square divided by 1 plus t cubed. And I can see it right away that the curve is discontinuous. If I put t is equal to -1, it's undefined. So both x and y are undefined at t is equal to -1. Okay, that's an important point to bear in mind. So I can change the a and I can change the t, and these two cells will compute the x and y value, and then I can make the plot. But what I was struggling with was I couldn't get the folium just this way that Wolfram got it. Probably you need to use Mathematica or MATLAB or Maple to plot that, but I couldn't succeed that. If any of you had better ways of plotting this, please let me know. So this is using the Cartesian coordinates, so plotting the folium of Descartes using the Cartesian coordinates. The same could also be done using the polar coordinates in terms of sine theta and cos theta and the R. I think, yeah, I'll leave it there. Okay, so that's where we are. So we've got this intersection of the curves, the point 6x, and two different solutions. And plotting it, and we've learned something called the folium of Descartes, implicit functions, how to plot implicit functions, and that's it. Thank you for watching.